Hi everyone. Here I'm going to start just making videos of the lesson, and I'm going to post them. So you can go ahead and watch them over and over. You can watch them anytime, many times you want. You can go over and over and just learn the lesson in your pace. So I decided not to do online teaching hours with you, that I can ask you to be online at a certain time, because this is hard for all of us to maybe be online at a certain time. Maybe you are with your kids at home and many difficulties that we all have. So I make videos of the lesson, I post them. You can watch them anytime, you can watch them anywhere, you can watch them over and over. And if you see I make a mistake, just let me know. I give you bonus mark, because it's totally obvious I may make mistake. Okay, so that's one point. And if you see still you have difficulty understanding a topic, also you can email me anytime. Okay, so here I start the lesson. In Math 171 we have 8 reviews, and we have then topics, topic 1 to topic 19. So you can see I posted all the topics, but I'm going to do videos of them and teaching you using these videos. Also, we are going to have office hours every week, and before the office hours I want you to send me your questions, and then I can do the questions during office hours. um so it's going to be this way. I still didn't do the introduction for the course, so I'm going to do that almost close to beginning of the course. So in the introduction I'm going to talk about everything. Here I'm just going to start the lesson. The lesson, the review one that we have in this course, we start from numbers, real numbers, and positive, negative numbers. So before we start the lesson, I show this question to a student and I say, what do you think is the answer? So you just see several fours and several operations: addition, subtraction, multiplications, and we want to know how to do. And you might say different answer, and then I'm going to tell you we need to know about numbers, and we need to know about operations, and we need to know about order of operations. So which operation comes first when I see several operations in the question. Okay, so here we can come back to this question later when I teach bed mass and just order of operations. So if I forget, just please remind me that I have to do this. Okay, so just 1 second. So let me check here what's going on. So here, yeah. Okay, so fundamentals or foundations of mathematics. So foundations of mathematics is where we start to talk number sets. So when I talk about number sets, I can know many things about numbers, and after that I can learn about operations on numbers. So we start with natural numbers. Natural numbers, I show the symbol. The symbol is this. So n with this line beside, in order to just make it different than just different with n. Okay, so natural numbers are counting numbers. So maybe because my handwriting is not very good, so I can just type it here. So they are counting numbers. So when we want to count, so we do, so what is the example? So we'd say 1, 2, 3, so those numbers. Okay, so some books they start from 0, but from my point of view, natural numbers, we just start from 1. Okay, and then I talk about whole numbers, and I show whole numbers like that, and I add a 0 here because whole numbers are natural numbers, but 0 will be added. Okay, So here, sometimes I see a student when they want to define natural numbers, they say it's whole numbers without zero. I cannot do that here because I still didn't define whole numbers. I have to define whole numbers first. Okay, so when I do that, then I can continue. Okay, so right now I defined natural numbers, so now I can use that definition. But the definition in mathematics, definition must be really just independent, not dependent to something else, unless I define that first. Okay, so here I can say whole numbers are this guy when I add zero to it. Okay, and in mathematics, when I want to add another member to another set, I can use this. So, and this is called union. Okay, so called union means I am having these all together. Okay, so it doesn't matter, you don't need to know all of these things, so you can just say the examples are 0, 1, 2, or you can say here, for example, I showed this set like that. When I use dot because it continues forever, and I can say I showed this one with that 0, 1, and 2 and 3 and go on. Okay, so examples are these. Integers. Integers are whole numbers and negative whole numbers. Okay, negative whole numbers. What do I mean here? Here is 0 is here, 1, 2, 3, and these, -1, -2, and -3, and all of these here. Okay, so these are just all are integers. So when I have 0 and positive natural numbers, those positive whole numbers are positive. I just have whole numbers and also negative whole numbers. So when I add them all, so here, for example, I can say -3 and -2 and 0 and 1 and 2, they are all examples of integers. And I show integers with z, but I use a line just in order to say this is not z, this is integers. So when I see that symbol, okay, so I'm not sure what's wrong with the OneNote here. So yes, I can move it now. Okay, so rational numbers. Rational numbers, I show them with q, and I say q is something like a over b, okay, fraction. But that's not enough. I cannot say all fractions are rational numbers, because maybe I have, for example, pi over 2. Pi over 2 is just a fraction, but it's not in Q. It's not in Q at all. Okay, so I have to say something else. I have to complete my definition. My definition must be completed. So this is a over b when a and b are just in z. So I cannot use any other number. So I cannot use pi, I cannot use e. I have to use, so pi and e you will see in future. So I have to say top and bottom should be in z, should be integers. So 1 over 2, 2 over 1, okay, so negative of them, so they are all, and I have to also mention that b cannot be 0. Denominator cannot be 0. If I have denominator equals 0 in math, that's undefined. I cannot have denominator over denominator 0. Okay, so I'm not sure what's the reason I cannot. Yeah. See, if I have, so 0 over 5, that's just 0. This is a 0 pizza divided between 5 people. It's 0. But if I have 5 over 0, that's undefined. Okay? And if you say 5 over 0 is infinity or minus infinity, it means you know a little bit of calculus, and that's wrong, because that's in limit, and you will see that in future in Math 270. Okay, so if I have real 0 in denominator, that's the undefined. Okay, so I cannot have that. So here, yeah. So I have to mention this. Okay, so I can show you this 1 over 2 or 2 over 1, or for example just 4, because 4 is just 4 over 1. Okay, so I can say 0 as well. I can say minus 3 over 5. All of them are rational numbers. Irrational numbers, those numbers, they are those numbers. I can type it here. So those numbers that cannot be written as fraction of two integers. Simply means when the number is not rational number, it's irrational number, and I can show it this way. In mathematics, when I have a set, for example, a set is A, if I want to say numbers which are not in A, I use C here. I use C at the top. So it's Q complement. Q complement means whatever is not in Q. Okay? But again, you don't need to know these symbols. If you just say irrational numbers, I accept. Okay? I want to just show you completed thing. Okay? So numbers that I cannot write as fraction, I cannot. So I cannot write them like A over B, A and B are in Z. I can't do that. Okay, they are irrational numbers. Pi, which you all say 3.14. But remember, 3.14 is not irrational number. It's just approximate for pi. For pi, you have to use your calculator. Okay, so you say pi here, or for example, radical 2. When you use your calculator, you see radical 2, many digits you see on the screen, so it doesn't stop. Okay, goes forever. Radical 3, how about radical 4? No, radical 4 is 2. I can use my calculator for that. Okay, radical 5. Okay, so they are irrational numbers. Real numbers, real numbers, I show them with R. I show this here. So they are Q and Q complement all together is real numbers. Okay, so I can use any of these are just pi, radical 2, radical 3, radical 5, not radical 4, because this is 2. Okay, so not that. Okay, so I can use any numbers here. So I can use 0, I can use 1, I can use 1 over 2, I can use radical 2, I can use pi. All of them are real numbers. Imaginary numbers. Imaginary numbers are those numbers that if you square them, the result is negative. Those numbers, oops. Okay, those numbers, when you square them, let me see if I can type here. Okay, those numbers whose square is negative. When you square them is negative. Okay, so for example, radical minus 2. If I square them, the result is negative. By square, I mean power 2. Okay, square means, for example, here, square of A is a power 2. Okay, so I can show it this way. Yeah, so those numbers whose square is negative, so means, for example, I squared is, no, I can't say means I, so I can say, for example, it has I. Okay, it has I, that I squared is minus 1. Okay, so For example, here I can, instead of, okay, so here I can, so here I can say, let me see, here I can say, for example, this is radical 2 multiple radical minus 1, which is radical 2i. Okay, so I can say I is, here I can say I is radical minus 1, and I can say I squared is minus 1. If I do a squared, if I do I multiple I, that's a squared. Okay, so these numbers, they are imaginary numbers. For example, radical minus 3, which is radical 3i, when I can write the number as I, that's imaginary numbers. So radical um, minus 4, which is radical 4i, which is 2i. Okay, so these are imaginary numbers. And also we have complex that you can see in the website that I shared with you, in order just to have more example for you. You can see them, but we really don't work with imaginary numbers and complex numbers. Okay, now I can give you another definition, and just in terms of rational and irrational numbers. You can see rational and irrational numbers here. Okay, so let me see what's going on. Okay, yeah. So in terms of decimal numbers, I can define. So see here, I defined rational numbers are numbers that I can write as fraction of two integers. Denominator is not 0. And irrational numbers are those that I can't. Here I can define them in terms of decimal. Okay, I have terminating decimal, means they terminated, it's 2.5, nothing after 5, 3.28, nothing after 8, 9.81, nothing after 1. And I have non-terminated, that they continued. In continued one, which are here, I have some which are repeating and some which are not repeating. If they are not repeating and they are just going on and on with different digits, and I don't know what is after, I cannot memorize them, so they are irrational numbers. But if they are either terminating or repeating, they are rational numbers. If they are neither terminating, means they continue, and they are not repeating, they are irrational numbers. These numbers are like 1 over 3, which is 0.3333 forever. And how do I show that? I show this 0.3 repeating. When it repeats, I use this line top of that. Okay, so that's repeating. So maybe I can show it more beautiful here. Yes. Okay, it's repeating. Or it's terminating. For example, 1 over 5. 1 over 5 is 0.2. This is terminating. 1 over 2, which is 0.5, terminating. They are all rational numbers. Those numbers which are neither terminating nor repeating, they are irrational numbers. And you can see them with just your calculator. If you use radical 2 in the calculator, you see radical 2 is here. It doesn't mean after 5 there is no digit. It continues forever, but I don't know what. If I say 1.4, 1.41, that's approximate. So for pi, How about for pi? Look at pi. So I know for pi, you use 3.14, many of us. When we are not using calculator for pi, we use 3.14. That's a very good approximate, but it's not pi. 3.14 is terminating and it's rational number. So we can't do that. Okay, see, pi is not 3.14. 3.14 is 314 divided by 100 and it's rational number. Pi is irrational number. And I know it's a good approximate, but it's wrong. I have to use my calculator for pi. Okay, and you see on your calculator a pi that you have to use it every time, because digits are very important for your program. So how many significant digits, how many digits you have to show. So we will learn all of these things. So you will see that digits, every digit is important, every digit is meaningful. So you cannot do whatever you want. So we cannot use 3.14 for pi. We have to use our calculator because pi is not that. I know that's approximate, but it's not. Okay? So I can show you this picture here. I have natural numbers here. All natural numbers are whole numbers because I just add 1 0. And maybe that's not a good picture because I just add 1 0, but it's much bigger. But n is inside n0. Both of them are inside z because z is the same as them, but it has negative numbers. All the same. All of them are irrational numbers. They are all rational because I can write them as fraction. I can write 1, 1 over 1. I can write 2, 2 over 1. I can write 3, 3 over 1. So they are all rational numbers. Irrational numbers are separated, and all of them together is R. Okay? So kind of R is the mother set. Okay? So that's just the picture that you can see here to have good understanding of number sets. Okay, so anytime you have just question, make sure to watch the video over and over you want, and you can ask your question by email. Okay, so I can help you with that. There are a number line showing numbers from -3 to 3. Okay, so how do I do that? I want to make a number line, so I make a line here. When I say number line, I have to remember, so what is my number? I have to check. Maybe I say the number is from 1 to, the number is from, for example, let me see. I don't know what's wrong with the file here. Okay, so I'm not sure. Yeah, maybe I tell you the number is from 1 to, for example, from 10 to 100. Okay, so then you show me differently, because it's 10 to 100. You have to look at from what to what. I have from -3 to 3. I have to ask myself, do I have negative? Yes. Do I have positive? Yes. Do I have equal? Yes. -3 to 3 equal. Equal negative, equal positive. So I have to use 0 in the middle. I have to use 0 in the middle. Then I have to see from what to what. Oh, from -3 to 3. So it's not too many numbers. So I can show with bigger space. But remember, if I say this is equal 1, I have to continue the same way. 1, 2, and 3. And here I can say -1, -2, -3. So I have to really see what number to what number. If I have, for example, 100 to 1000, then I don't need to show negative. And I don't need to show very big space. Or I can do 10 by 10. I can do 100 by 100. It depends. So it depends on what to what. So we do negative numbers here. We do positive number in right side, negative numbers left side. We do 0 in the middle. And we call all of these graphing techniques. When I ask myself, do I need to have positive and negative? Yes. Do I need to have equal? Yes, because it's minus 3 to 3. How do I divide? Oh, I can show big space for 1 unit. This is 1 unit. This is 1 unit. I can show one big space because I just have minus 3 to 3. I don't need to go small. But if you show me this way, it's not wrong. You show 0 in the middle. You show 1, 2, 3. You show minus 1, minus 2, minus 3. You have them equal spaced, but you are not using this side and this side. And this is not good graphing techniques. Graphing techniques, very important for your program because you need to graph for the lab work, okay, in future. So it's very important for you to learn how to graph. So you have to use your graphing techniques then. And that has mark. So what do the arrows at the end? So here I have to, so I'm not done. I have to add arrows here. And these arrows shows it continues. So it shows it continues to, so it, I'm not sure why it doesn't type. Oh, it's doing, okay. So it continues to infinity from right and negative infinity from left. What does the term scale mean in terms of numbers lines? What does the term scale mean? Okay, a scale means I have equal space between equal numbers. Okay, so I have equal space, equal spacing between units. Okay, so it means you don't show me this way. See, for example, if I show this, many times when I'm marking, I see a student. When I'm teaching, I always talk about mistakes that I see when I am marking because I don't want you to do those mistakes. So just pay attention. I don't want these mistakes to stick in your mind. But when you just listen to them and see these, so you just remember when you are doing the exam. Okay, so sometimes I see a student, they do that. So they do 1 and then they do 2. Okay, look at this. I have 1 here and I have 1 unit here, but they are not the same. This is wrong. I have to have equal spacing between equal numbers, between units. Okay, equal spacing. So when I say 1, that space should be equal from 0 to 1 and from 1 to 2 and from 2 to 3 and all of them. So here it says order these numbers. Okay, so I have to order these numbers. So order the following numbers from smallest to largest, means from minimum to maximum. And remember, number lines are like that. So I go from negative to positive, means I go from a small to large, and 0 is in the middle. Okay, so I need to look at my numbers here. Equal spacing, clear labeling. Okay, so what is my maximum? Maximum is 4, right? Maximum is 4. So I have 4, I have 3 minus 2, 0. Yes. And I have also minimum, which is minus 2.5. This is minus 2.5. So this is minimum. Okay? Maybe it's not a good time to talk about these numbers because I still didn't teach you fractions. Okay? But this was part of the lesson. So for this one, this is minus 1. For this one, I can use my calculator. So this is, what's wrong here? Something is moving. Okay, so this one is 1.7. This goes forever. It's irrational number. I know this is approximately. Okay, that's minus 2.5 here. This is minus 2, 1 over 2, so which is minus 2.5. Okay, we will see this in future in fractions. And also 4. Okay, so 4 minus 2.5. Is it equal? No. Do I have negative, positive? Yes. But it's not equal. One of them 4, one of them minus 2.5. But it's not there is no big difference. Okay, so I can make a line here. Yes, I need 0, but I need 0 here, not in the middle, because I need more space. I go to 4. Because it's just 4, I can make a bigger space between to each unit. So I have 1, 2, and 3, and 4. And I have minus 1, and minus 2, and minus 3. And this is here, minus 2.5. Okay, so the minimum number is here. I can show it. 4 is here. I can show it. Minus 2 is here. 0 is here. 3 is here. What is pi? 3 point, I said 3.14. It's not pi, but it's approximate. So I don't have any other choice. I have to use that. I have to say this is, somehow I have to go closer. Okay, so yeah, so I have to go closer here and I say this is pi. Okay, so almost. And that's pi. So did I show 3? Yes. 0? Yes. Minus 2? Yes. Pi? Yes. 4? Yes. Minus 2.5. Minus 1? Yes. And radical 3, which is 1.7. Okay, 1.7, if I just approximate, if I go from 1 to 2, so it would be here. This is radical 3. Okay, so I show them on the number line. I have equal spacing. I have clear labeling. I have everything beautiful. And I'm showing, but for these are approximate, for these approximate, okay? But for all other numbers is exact for my scale, exact on my number line, okay? So clear labeling and clear everything. Okay, so what type of number is pi? Okay, pi is irrational number. Irrational number, pi is in Q complement. In mathematics, when I want to say a member is inside another set, I showed this. This means pi is member of this set. I don't need you to know all of these symbols. I don't need. You can say pi is in, just is irrational. You can write me in words, just English. I accept. Pi is not 3.14. 3.14 is 314 divided by 100. It's rational number. Pi is irrational number. So I can stop here for this video and continue after. Okay? So I appreciate your time. You can watch them over and over. If you see I made a mistake, email me and let me know. You can email me anytime. I prefer your email to come before 9 p.m. every day. Okay, not after. Thank you so much. Follow the lesson. Bye.